Yes, welcome you all. So today we are going to discuss about the shear force and then a bending moment along with the bending stresses. So normally when we discuss about the shear this bending moment and about an bending the stresses, first we should know about the what do you mean by a shear force or how the forces will be acting at a different conditions and how the bending moment will get reflected to the shear force. See, whenever we apply any load on any component or any product, so there will be some reflection. So that reflection is might be in a resisting or might be in a bending. So in certain cases, if the material is not able to resist the force which is acting from the forces which is developed or which is uh, applied on the load, applied loads on the any components or objectives, when it can't able to resist, it starts the bending. So due to the bending, whether the material can able to withstand the loads, but after certain it may have any chances of failure also that material. So again in that the what we're going to study about in a bending stress. So the bending stress is nothing but stresses what we are going to be developed or what the stresses which the stresses is going to be developed from the because of the load which is acting from the shear force and in a bending moment. So first we're going to look at about the what are the objectives that we're going to study about shear force and then bending moments in this especially in this model. So mainly we're going to study about the shear force and then a bending moment. Mainly we're going to focus on about the shear force and then a bending moment diagrams, and we're going to discuss about the behavior of beams under a different loads. See, all the materials or all the loads will be act or will react or will get a reflection for a different types of load based on the forces which is going to apply. See, all the loads cannot be applicable for any same condition. So all the beams mainly in this especially mainly are we are going to discuss about the beams. See, the bending or shear force will even all the materials, but mainly we are going to focus about the things in this model is about the beams. So how the beams will be act or what are the different types of beams and how the beams will going to be react for different types of load. See, all the beams cannot be used for all the loads and all the load applicable for all the beams. See, uh, depending upon their usage where we are going to use. See, mainly the beams is comes in the buildings. See, whether it might be a normal building or an house purpose building or in a commercial building. It depends upon the customer requirement. The construction of house will take place depends upon the customer requirement. See, based on the customer requirement, the engineers will going to build that particular houses. So when we building the houses, where exactly the load will comes. So how the load will be distributed? What are the types of beams that has to be included in the construction of the house at different areas, right? When if you take in a normal house, when if you go for an multi-storage buildings or in a commercial complex, so how the construction will be processed? For example, if you take as in a bridges or in a metro, see how the bridges will be developed. See, so many vehicles will be traveling on the bridges continuously for an 365 days into 24 hours, right? So when where exactly the load will be distributed on the bridges, whether it might be whether the load will be distributed on the pillars or on the lanes where it has been constructed. See how this all this has been calculated based on the usage where the application of this particularly where the these types of beams has been used. There particularly we are going to use the types of beams which can able to suitable for the conditions, right? So then we're going to study about the stresses. Mainly what are the stresses? The stress is nothing but a load by area, load which is acting on that particular area, what it can able to cause to that particular area or particular material, that we are going to in depth we are going to study. And the bending stress derivation and deflection behavior of the beams. Like this we are going to study about the completely about the beams, what are the types of beams, then what are the types of loads, then the shear force, then the bending moment, along with how we can able to draw the shear force and then a bending moment for any different types of loads at any different conditions. Then we can able to draw for then we will discuss about this completely about the stresses induced in the beam, then about the behavior deflection when the bending moment or deflection takes place on the beams, how the beams will behavior at any different load conditions. So these are all the things we're going to study about. Then we're going to study about the types of beams, shear force, bending moment, shear force diagram and then a bending moment diagram. And we're going to study about the relation between the shear bending and then a moment. Then we're going to solve the basic examples of how to be able to draw the shear force and then a bending moment. Then we're going to discuss about the pure bending. Then that is what we call as an stresses in the beams. Then the assumption made in the bending theory. Then we're going to discuss about the deflection of beams. So these are the some of the learning structures that what we're going to discuss are completely thoroughly we're going to deal or discuss about the shear force and then a bending moment in this model. First, mainly when you come to the types of beams, see the beams is and the columns are very important in order to take any load on the structures. So mainly the structures is nothing but whether it might be in houses or whether it might be in a commercial buildings or whether it might be in a metros or in a bridges or railway tracks. So all the things are mainly depends upon the reaction or reflection when we apply the load on any component or any object, whether it can able to sustain or not. First thing. Then next one is about what are the which type of application is suitable here. All the materials we are discussing from beginning also, all the materials cannot able to be applicable for all the different conditions. See, one or the other material will be used for a different types of or a different conditions, but the similar material or the same material cannot able to be applicable for all the conditions, right? So this is how similarly, for example, we have any different types of beams, mainly this columns and beam. Before going to the beams, we should know about the columns. What is the purpose or what is the function of the columns is to withstand the load. See, all the load will be buried on a columns only, then only for the supports of the columns we are going to use the beams. So what is the function of the beams is to take the load where the load will be exactly. If you take in a roof, the roof of the load will be on the walls. So to support that walls is going to support for the columns. So in order to support the columns or to take the load equally distributed load, we're going to use the beams. So the beams are depending upon the support. Mainly there are the different types of beams are there. Mainly we can able to see the beams. Even the beams also it's in a load taking, like columns, how the load will be taking columns of the entire roof or an entire building or an entire structure. Now we can able to see the so many pillars are there been constructed in the metro. Why that pillars is, the pillars is taking the load, where even the beams also along with the structure where it has been on the road, it has been included. But even though the pillars are very important or major factor that it going to takes the load, right? This is how similarly the beams also it's one of the type of load bearing supports only for the columns. Even in the buildings or house holding purpose, all the constructions we mainly we're going to use this in a beams. So beams also one of the element or a component that it can able to take the load for different conditions, right? Where we are going to use the different types of conditions. Why the different conditions made to the picture is because the beams are in houses, it is not made in any standard dimension. So it is all the depends upon the requirement of the customer, right? How we going to build houses based on the requirement or based on the interest of the customer, right? Similarly here also we are going to discuss based on the different types of beams along with their usage and the support. First, mainly you can able to see the cantilever beam, simply supported beam, overhanging beam, continuous beam, fixed beam, and it is a depends upon the cantilever simply supported mixture where it is used for depends upon the requirement or the application or requirement from the customer. First, mainly we can able to see the cantilever beam. So the cantilever beam is nothing but the beam which will be having a only one side support, other end it is a kept as a free, or it is what we call it as a free end. No support will be there on the other end, only one end will be fixed. We can able to see, sorry, only one end you can able to see this is where you can able to see this end will be completely fixed and other end is kept as free. So this type of beams has been used in the construction purposes, where you can able to see the porticos or for where the decoration type where it is use these beams for mainly in the porticos. So porticos you can able to see that beams has been only one end has been fixed to the roof and other end has been kept. So on that only they're going to make some other decorations or other type of designs in order to look the house with a very neat purpose. So similarly next one is about the simply supported beam. So for the simply supported beam, both end will be having a support. So both end, one end it might be fixed, other end it might be having some other support like a roller support or an hinge support like this. So we'll be having the both end support, whichever the support if we take in a simply support. So the simply support beam will be having the both ends will be having the support. This type of beam will be called normally is in a simply supported. So this type of mainly be used beams on the walls on the both end of the walls. So the beam will be located on the both ends of the walls and it is attached to the roof in order to take the